Owls have a remarkable ability to rotate their heads up to 270 degrees in either direction, giving them a total range of about 540 degrees without moving their bodies. This extraordinary flexibility is primarily due to unique adaptations in their neck anatomy, particularly the structure and number of their cervical vertebrae, along with specialized vascular and muscular systems that support this movement. Below is a detailed explanation of how this works. 1. Extra neck vertebrae owls possess 14 cervical neck vertebrae, compared to the 7 found in humans and most other mammals. These additional vertebrae provide greater flexibility and range of motion in the neck. Each vertebra is relatively small and loosely connected, allowing for more independent movement between them. This increased number of vertebrae creates a longer, more flexible neck that can twist and turn to a greater extent than in animals with fewer vertebrae. Structure of the vertebrae. The cervical vertebrae in owls have specialized shapes with wider gaps and more flexible joints, called synovial joints, that allow for smooth rotation. The vertebrae are also equipped with small bony projections, transverse processes that provide attachment points for muscles and ligaments, aiding in precise control of head movements. Pivot points. The atlas, C1, and axis, C2, the first 2 cervical vertebrae, are particularly important. The atlas allows the head to pivot around the axis, enabling significant rotational movement. In only 3 mammals, these vertebrae are adapted to permit a greater degree of rotation than in other animals. 2. Muscular and ligament support. The muscles and ligaments surrounding the owl's neck are highly specialized to support extreme rotation. Neck muscles. Owls have strong, flexible neck muscles such as the sternocleidomastoid and splenius muscles, which control head movement. These muscles are arranged to allow precise, controlled rotation without straining the neck. Ligaments. The ligaments connecting the vertebrae are elastic and allow for significant stretching and twisting, providing stability while permitting the head to rotate far beyond what most animals can achieve. 3. Vascular adaptations to prevent blood flow. Issues rotating the head. 70 degrees could potentially twist and constrict blood vessels, cutting off blood supply to the brain. Owls have evolved unique vascular adaptations to prevent this. Wide arterial openings. The carotid and vertebral arteries, which supply blood to the brain, pass through large bony canals in the vertebrae called transverse foramina. In owls, these canals are much wider than the arteries themselves, up to 10 times the diameter, allowing the arteries to remain untwisted and uncompressed even during extreme head rotation. Reservoirs for blood. Owls have specialized structures called arterial reservoirs or vascular loops in their necks. These act as slack in the blood vessels, allowing them to stretch and coil without kinking as the head rotates. This ensures continuous blood flow to the brain. Collateral blood vessels. Owls also have a network of smaller collateral blood vessels that can take over if the primary arteries are temporarily constricted, further ensuring that the brain receives oxygen during extreme head movements. 4. Nervous system protection. The spinal cord and nerves in the owl's neck are also protected to accommodate head rotation. Flexible spinal cord. The spinal cord is highly flexible and surrounded by a protective sheath that allows it to twist without damage. Large vertebral canal. The vertebral canal, which houses the spinal cord, is relatively wide, reducing the risk of compression during rotation. 5. Why owls need this ability? Owls' head rotation is an evolutionary adaptation tied to their lifestyle as nocturnal predators. Fixed eye position. Owls have large forward-facing eyes that are fixed in their sockets, meaning they cannot move their eyes to track prey. To compensate, they rely on head rotation to scan their environment, giving them a wide field of view without moving their bodies. Stealth hunting. Owls are ambush predators that rely on silence and minimal movement to avoid detection. Rotating their heads allows them to track prey or monitor their surroundings while remaining stationary, reducing the chance of alerting prey with body movements. Enhanced vision and hearing. The ability to rotate their heads complements their exceptional binocular vision and acute hearing. Owls can pinpoint sounds using their asymmetrical ear placements and then rotate their heads to align their eyes with the sound source, improving their ability to locate prey in low-light conditions, source source, limitations, and mechanics. While owls can rotate their heads up to 200 degrees in either direction, they cannot perform a full 360-degree rotation. The 2-degree limit is due to physical constraints imposed by the length of the blood vessels, muscles, and ligaments, which can only stretch so far before risking damage. To achieve this rotation, owls often rotate their heads in a smooth, controlled manner, sometimes using a series of quick, jerky movements to reset their head position. They may also tilt their heads in a motion called roll to further adjust their field of view, complementing the rotational movement. 7. Comparative anatomy. Compared to other birds, owls' neck anatomy is particularly specialized for rotation. For example, many birds have flexible necks, but few can match the owl's range of motion. Hawks and eagles, for instance, can rotate their heads about 180 degrees, but their fewer cervical vertebrae and less specialized vascular systems limit their range compared to owls. 8. Scientific insight studies, such as one published in 2013 by researchers at Johns Hopkins University, used CT scans and dissections to reveal how owls' vascular adaptations prevent blood flow. Interruption during head rotation. This research highlighted the role of the wide transverse foramina and arterial reservoirs, providing a clear understanding of how owls achieve this feat without injury.